Hey everybody, welcome back to Don't Wait Automate. My name is Mike Davis at All Control Enterprises, and today is finally here. We're talking TM. We're talking Omron TM. Easy. George wants to be safe too. I don't blame him. Here we go, George. How convenient. We're good. Now that we got our daily dose of fun out of the way, let's get down to business. So today's video is again the collaborative Omron TM robot. This is a power enforced limited robot, which means that it's actually engineered to be next and close to humans in order to interact and be able to be efficient on the manufacturing floor. So for comparison and understanding, I wanted to talk about how collaborative robots compares to industrial robots, the robots that have been around in our manufacturing floor since the 60s and been incrementally innovated ever since. So with industrial robots, you're dealing with fast style applications. Cycle time, heavy payload. We're talking contracts that require hundreds of thousands of these parts moved, sometimes even in a day. Whereas collaborative robots are more on the high mix, low volume. We're going to be looking at very rudimentary, mundane tasks that should be automated using a robot and not using a human. In today's culture, we're going to be seeing a huge shift in terms of having an operator be more value add and creative, being more of that manager of that cell rather than just the task doer. So, what are the benefits of the Omron TM over other competitors in the market? To start off, one, Omron is a large automation company. They have many different types of products, from inputs, controls, and outputs. So the robot falls right in that family. And of course, number two, we got integrated vision. Why is that important? Well, close your eyes and try to pick up something after someone moves it. You might miss it. All right, now that we know the differences between cobots and industrial robots, let's get into the demonstration and probably the most popular application for these cobots. What application is that? Pick and place. So hypothetically, let's just create a scenario here. Let's say I'm a plastic injection molding company and I'm gonna need to have either an operator or a robot take the actual injection molded parts that have been degated from the Cartesian robot coming down the conveyor towards the end and has to be put into a box, a pallet, or some type of nest. Let's face it, I don't have an injection molder right here in my basement, but I got a 3D printer. So I printed out 4 of these cubes that it's gonna pick up and then be able to put into this pallet / nest, whatever you might wanna call it. So again, those parts are coming off the conveyor. The robot will, again, use vision to detect and pick up based on its coordinates, move over and place it using this landmark right here. And this is a very cool feature with this robot. Easy application, easy programming. It looks complicated, but trust me, it's not. What we're gonna do is simply have the robot look over some type of landmark feature, which we have here. Pretend this is the end of that conveying line for the injection plastic parts. It's gonna come down, pick up the cube based on the TM landmark. It's gonna swing over and drop it into its nest, final resting place, whatever you wanna have it. And then it's also gonna use that TM landmark to make sure it's orientated in the correct way for its first, second, third, and fourth spot. Okay, looking at the TM Flow software, you can see that the program has already been kind of laid out, and I wanted to do this just for demonstrational purposes. This took me around 30 minutes to complete, was not hard. And of course, we just got to make sure that we go through it in a methodical process. I started the program, now we're running. It hasn't started the process yet because I paused it, but I want to show the flow of the program as the actual robot is moving so you have a good idea of what's going on. I'm going to press play. The robot is going to find the landmark. It's going to approach, pick it up, swing around, approach the pallet nest, determine where it is, and place that first part. We're going to repeat the process, and now we're going to move. So that way we try to get an idea how this actually compensates. Because you have to understand, manufacturing facilities are going to be different in every aspect and shape and form. Customers will have different priorities, different specs. You're going to need to be able to be moving and be variable on the fly. This is the best tool that you can use that gives the capability of a flexible and deployable solution because the robot has eyes. If the robot has eyes, it's almost unstoppable. And now since we've completed, we have a variable count in here on my if statement that says if we reach 4 to continue and say pause, so it's waiting for me to load up the board again before we start a next, and I press play, and then it recycles, it resets the count back to 0, and then we restart our pallet. As always, thanks a bunch. All Control really appreciates you guys watching. We're going to be really showcasing this TM. I didn't really go into the flow, but I want to show how intuitive it is. I want everybody to understand that you just have to think. You move, that's a point. You trigger, grip. You move, and if you just have that kind of mentality, it's going to be a cinch. George is mad at me now.